Hello, everybody! This is Tomek, and you are watching the second episode of my Devlog series. I am still thinking of the name for my project, and I also have been struggling with creating the rivers on my planet that I told you about in the last episode. I'm still not getting the results that I wanted. Anyway, as I do not have much progress to show you at the moment, I will talk about the basic architecture that I used to create my planet object. And now what you are seeing right now does exist, even though you can't see the stars. So, as you can see here, my intention is to have a spherical object, which is based on a series of points that create a map for the game. I tried 2 attempts at this. The first one seemed the logical way to go about things, so I gave it a go. The idea is to start with a single mesh object in 3D space. In 3D graphics, a mesh is a grid of vertices or points in 3D space that are connected into triangles. So at each intersection, all the different intersections here, you have a point defined by x, y, and z coordinates. And then I define how those points make up the triangles. This information is then passed on to the graphics card, and the mesh of triangles is displayed on the screen. Of course, there is much more into this. For instance, there is additional information that a vertex can have. It can have normals, for instance. It can have texture coordinates and other information. So, yeah, I'm not going to go into details on this. Maybe if you request more information, but not in this video. Anyway, I start with 2 square meshes that you have here. You only see one because they occupy the same space. I then rotate one around the x-axis to get a result like this. So you can pretty quickly see where I'm going with this. In fact, I was not really completely honest with you. I did not put 2 squares here in the beginning, but 3. And now when I rotate the 3rd square, I get something like this. So you see that I'm going in the direction of a cube. So this is a cube, but in the back, you can also imagine that I rotated another 3 faces to get a full cube. So coming back to our vertices, each vertex is defined by a vector in 3D space. And basically a vector defines a direction and a magnitude. Like so, from the origin to the point in space, the x, y, and z point. If we consider that we have a cube and we want to obtain a sphere, the easiest way to do this is to normalize the vectors. Or put it differently, keep the direction but change the magnitude to be 1 unit length. You can imagine it can be 1 centimeter or 1 kilometer. I don't mind, whatever works for you. For a cube, this will have an effect that it will pull in the corners and edges more to the center of the cube than the faces. And those points will have the biggest change in magnitude shift. You get something like this. Now, there was some rotation here in the animation, but bear with me, there is no rotation, there's only deformation. So you see that all those points that make up this cube are squished into 1 unit length. Now, I would be happy about this. We are done. We have a sphere and we have vertices to which we have access. And if we wanted to create a game where we only see the planet, we could perhaps accept with pleasure the fruit of our labor. But alas, this is not yet what we require if we want to put in some more advanced logic, like pathfinding territories or for different players. You get the drill. So what is the issue, you might ask? This is the issue. Here you see the vertices of the front face. Notice that there where we have the edges, we get duplicate vertices. This will initially screw up graphics and lighting. Nota bene, in 3D graphics, light is calculated by pointing a light on a surface and bouncing or reflecting from that surface based on a normal vector. That is also stored on the vertex, this normal vector. In order to calculate the normal vector, we need to know the position of all the vectors around our target vector. So if we want to calculate here, it's We are looking at all the neighbors that are around, and based on information where those neighbors are, we can calculate the normal vector for that vertex. If we are on the edge, however, then we have no information about those vectors because the neighbors are in another face. And therefore, we cannot calculate a proper normal vector and will get wrong results. What we will get are lines like this, seams between the faces, or as I like to call it, the ball effect. Anyway, this not knowing who your neighbors are from a vertex point of view is also a serious issue if you want to do pathfinding, territories, other game logic. You get the point, I hope. So I was playing with this code to make this work, calculating all those neighbors between the faces, all those normal vectors, but it did not seem to work. It did not seem to do the trick. I kept getting the ball effect all the time. So I decided to ditch this approach and go with, I believe, a more elegant solution. Yeah, let's destroy all that work that we did and let's start from scratch. First, I create points around a cube. No more creating of squares, no more rotating those squares. This has had some other issues later in the code. It was quite difficult to work with. But now when I created all those points with one go, I could easily connect those points into neighbors, into a huge network of points. Next, what I did was I grouped them in logical bodies, the top, the middle, and the bottom. Notice that the vertices on the edges at the top and bottom are shared between the groups. There is no more duplication. Also, at this point, I can also calculate all the normals and all the neighbors, as I've already told you. In fact, what I did was to create a MapNode class that will encapsulate all the logic I want to get from my map. So a single MapNode will have a position, so a vertex. It will have a normal vector. It will have a list of neighbors. It will have a list of distances to those neighbors. I can also add some more information like the elevation of that vertex, the biome it is part of, or if it's a river, if it has a road, if it's a town, a city, if it's a manufacturing plant, a farm, a resource, whatever. It's a logical element of the map of the game. And then, finally, when I have all those points, I can group them into smaller chunks and create meshes out of them. Now, before I said to myself that the logical game data structure that I was using was the mesh. It is not true. The real data structure that I'm using is the MapNode. The mesh is only a representation passed on to the graphics card. So this is basically the current architecture approach for the planet. It will most likely change with time, but I hope that I will not be moving on from the MapNode class, but instead perhaps optimize how I build meshes. There's a lot of optimization to be done here. Maybe I will add some level of detail. Maybe I will be creating only one mesh at a time, and I'll be just moving this mesh across the different points when I'm moving the camera. Maybe I will do some level of detail loading. I will most likely have to do some texturing and multi-texturing, perhaps, to get a better crisp graphics. But I hope that the MapNode class, so the basic structure that is under the hood, will stay the same. All right. Thank you very much for staying here with me. I hope this was informative. And don't forget to like and subscribe.